For this presentation, we have Vojtech Tauber. Vojtech is the Director of Technical Services and Product Management with Sika Corporation in the concrete area located in Lyndhurst, New Jersey. In 2005, he started his career with Sika and concrete industry in the Czech Republic directly after the university. He held a master's degree in concrete and silicate composite technology. In 2013, he was relocated to the United States and started a new journey with Sika Corporation. The main responsibilities with the current positions are maintenance of the current product portfolio of Sika mixtures, development of new innovative solutions and technology for Sika customers and the concrete industry. Welcome, Vojtech.
All right, guys. So, good afternoon. Thank you very much, Julissa, for the introduction. I appreciate the opportunity to basically share my experiences with you. In terms of agenda, it's going to be very simple. I have basically 4 main points here. I will share my experiences from Czech Republic and the USA. I'm going to basically present and show selected standards. We are going to talk about the industry challenges as well. And we are going to finish with the conclusions. So on this slide, you can see basically around 2005. This is where I started my professional work. It was directly after the university. I joined Sika Corporation, and I basically stayed in Czech Republic for 8 years. So I can say before the transition to US, I felt pretty confident because in 9 or 8 years I learned a lot of within the industry. So it was great experience. I moved in 2013 together with my wife to US, and we basically started a completely new life. So there are a lot of differences. You know, we basically have to learn a lot of new things. We have to adjust and adopt ourselves. And it took some time. So I'm going to talk about some work experiences that I had during this transmission. And this is what I would like to be also focused on. Czech Republic. Who knows Czech Republic? Who went to Czech Republic? All right, perfect. So Czech Republic is in the middle of Europe. It's a beautiful country. I basically tried to Google it, what is the Czech Republic most known for? So as you can see, there is a lot of beautiful things, and there is one very, very important thing, and there is a beer. Okay? We have one of the best beers in the world, and we are proud of it. So in terms of size of Czech Republic, and you can see it on this slide, we are basically 25 times smaller than US. Yeah, if you look on the map and you can see all the states, our size is basically equal to South Carolina. In terms of population, US more than 330 millions, South Carolina 5.5, and Czech Republic 10 millions. So this will basically give you very nice perspective about the size of the country. Differences. So first thing, when we came here, and we basically were like driving on the highways. So we see like distances, no kilometers, miles. Okay, so that was something new, but that's not the biggest challenge. Okay, another thing, beer. Okay, so in Europe, half liter, in US pitcher with no foam. So okay, good, something new. We adapted ourselves. Same thing with the steaks. In Czech Republic or Europe, usually half kilogram. Here, pause. Okay, so that was something new. Concrete in Czech Republic. Yeah, so it's basically concrete, correct? Water cement ratio, cement aggregates, water admixtures, durability, strength, slump. Oscar mentioned that. So in US, it's same concrete. Okay, the raw materials are slightly different. You are using different cement times, different aggregates, but it's same material. Another perspective. So in Czech Republic, it's 450 ready-mix plants. In US, we have 7,500 ready-mix plants. In Czech Republic, we have basically a lot of silos in the ready-mix plant. So we have a lot of options how we can create a concrete, how we can mix cementitious materials, SCMs, together with aggregates. Yeah, so we have basically, we can be much more flexible, and we have much more opportunities how to create good quality and durable concrete. In terms of challenges, I think it's globally everywhere the same. Everybody or all the countries are more or less challenging or facing the same or similar challenges. Availability of the raw materials, quality of the aggregates. You know, there is a shortage of the natural sands. Raw material shortages, you know, issues with the durabilities. You know, so I can basically name a lot of these, but I think that more or less we are struggling with the same issues. Key observations, US, go big or go home. Yeah, like for us, basically to came from small country in the middle of Europe, US is a huge country. Distances, unbelievable. Yeah, so it was big learning point. Production volume. Yeah, another important thing. In Czech Republic, average ready-mix plant is, let's say, 20,000 cubic meters of concrete. Here, it's unbelievable. The projects, Amazon centers, the slabs, again, huge, unbelievable. Mixed design, a lot of differences. Selection of the raw materials, again, a lot of differences. Setting characteristics. This is something completely new, or it was something completely new in Europe. Nobody is basically checking really deeply the setting characteristics of the concrete. It's very, very important thing. Durability of the concrete. I think US, it's much more durability driven. There is a lot of use of corrosion inhibitors, shrinkage reducing admixtures, push to basically reduce the water cement ratios. Yeah, so I think this is again significantly different. What I really like is cooperation between the industry associations. I was part of NCMA and ICPI, and I was basically a member of the technical committee. And what you are or we are doing basically here also with the ACI and ASTM, it's great. The way that industry is basically working together. In terms of standards, as I mentioned, we have ASTMs, ACIs, and so on and so on. In Europe, it's basically EN, European standard. If this is German standard, it's basically there's in front of the standard DIN. That's the basically identification of the country. In Czech Republic, we have ČSN, which is basically Czech standard. I'm gonna basically talk now about few of them. Yeah, so the main standard is EN 206, and as you can see, there is a lot of different standards after or below this norm. So I would like to be focused on two of them, on the cement and also admixtures. So if we are gonna go back to Czech Republic, small country, 5 cement plants, you can see basically type of cement that we have from CEM 1 to CEM 5. We have 5 cement plants. The overall production is 4.5 million tons of cement per year. And basically in those 5 cement plants, we can basically create 27 different types of cements. 27. Okay, so this is unbelievable. Again, if we are gonna basically talk about the cement specification, and it's basically EN 197, and this is probably very difficult for you to see it, but on the left side you have basically CEM 1, CEM 2, CEM 3, 4, 5, and on the top you have basically clinker or the content of the clinker, which is from 95 to 100%. And then if you go from left to right, you have basically limestone, slag, fly ash, and you can basically create like a blended cements if you are adding those main raw materials to the cement. What is also interesting in Czech Republic, we have basically 3 strength type of cement. So it's 32.5, that's compressive strength after 28 days. We have 42.5, and 52.5. So basically, based on the requirements of the concrete, if you are looking for low-strength concrete, let's say 3,000 psi, you are going to use the lower strength class of the concrete to basically meet the requirements. If you are looking for 10, 15,000 psi concrete, you are going to use higher class strength of the cement to basically meet the requirements of the concrete. In 2008 or till 2008, we had basically CEM1 42.5 R, or R, it's like a rapid. So that was 95% of the cement. And as you can see on this slide, it was basically 95 to 100% of the clinker. Yeah? So this is cement that was used for, let's say, durable concrete, 0.45 water cement ratio and below. Another cement type that was basically widely present in Czech Republic was CEM2AS 32.5 N. N means normal strength. And that was 80 to 94% of the clinker and 6 to 20% of the slag. So this cement was typical for the low strength concrete without special durability requirements. So what happened basically after 2010, in 2010 we started to basically switch the country to limestone cements. And you can see how the contents of the clinker switch. So we went from 95 to 100% of the clinker to 80 to 94 for the CEM1A, and with the other cement we went from 80.94% of the clinker to 65 to 79. So there is a huge reduction of clinker in this. Yeah, so we started this transmission probably 2009. In 2013, when I left Czech Republic, all the cements and all the customers were basically switched to 1L cement. Yeah, so it took us 2 to 3 years to basically went through this. And there were a lot of challenges basically linked with the switch. It wasn't like that you are going to switch cement 1 to 1 and everything is going to be just beautiful. Yeah, so we worked together on this as an industry between the cement producers, aggregate producers, admixture producers. And again, we basically adjust ourselves and our products and our approaches to make sure that we are going to continue to produce good quality and durable concrete. And if you look on this list of the challenges, I think that we are basically now in the US, I want to say, like, at the end of this transmission from type 1, 2 to 1L cement, and we basically went through very similar challenges. Yeah, so there is a lot of learning, as Oscar mentioned. There is a lot of correlation, and if we are going to basically work on those things together as an industry around the globe, I think it's going to help us to be better. So now, if basically we are going to move back to US. In the US, 95 cement plants, and production is 95 million tons per year. Yeah, so basically what we have 10 main cements. Yeah, so you can see it here. In the past, it was mainly 1, 2. Now we are basically moving to 1L, and this switch is almost done. Now we are going to basically leave the cement industry, and I would like to talk a little bit about the specification of the concrete in Czech Republic and Europe in general. So this is basically specification of the concrete in Europe. It's very simple. C30 to 37 compressive strength. XF4 exposure class. I'm going to talk about this a little bit later. CL maximum chloride content. Dmax is maximum size of the aggregates in millimeters, and S4 is basically for the concrete slump. So let's talk about the compressive strength. So compressive strength is basically divided, if we are going to talk about C35-45, C30 means maximum characteristics, the compressive strength on the cylinders, and 45 is basically on the cubes. So that's another difference. In Europe, all the strength is done on the cubes, here on cylinders. Chloride content, very easy thing. There is a specific number that you have to basically meet for the concrete. Same for the slump. If we are going to talk about the exposure classes, so this is basically, as you can see, from X0 to XA3, and there is a maximum water cement ratio, minimal compressive strength, minimal air content, maximum water penetration, and also freeze-thaw durability. And I would like to point it out, basically XF class, which is freeze-thaw attack with and without de-icing agents. So if you look on the specification, this class is basically driven by the water cement ratio, minimum cement content, compressive strength, air content. There is a maximum water penetration that you have to meet, which is, in my opinion, a very, very important thing, because water is good for the hydration, but it's not very good for the durability of the concrete. And then also freeze-thaw durability, number of cycles that you have to basically test on the concrete. So DIN 1048 is one of the methods that I really, really like, and it was absolutely common in Europe. So it's basically tested on the cubes. You are gonna put cubes, concrete cubes, after 28 days to this special device, and from the bottom there is the water pressure for 3 days. And at the end of this test, you are gonna basically break the cubes to half, and you are gonna basically see what the penetration of the water is. Yeah, so on this picture, if you look on the bottom picture on the left side, what do you think? Which one is the better concrete? The first picture or the second picture? Yes. Yeah, so again, very simple test. After 28 days, you can have some indications, you know, what could theoretically happen with the concrete. So this is in terms of concrete specification. So admixtures, that's my favorite part. So we have, or we had in Czech Republic, specification for the major admixtures. You can see it on this slide. Water reducers, accelerators, retarders. There is a big difference how this is basically done in Europe and in the US. So if we look on water reducing admixtures, yeah, so basically if you are gonna test water reducer, and you wanna have, product approved, according to EN 934, you have to do tests in the concrete. Everything is tested at equal consistency. So there are 3 parameters that you have to meet to basically be approved according this standard. It's basically water reduction, so you have to have basically 5% and higher water reduction. You have to meet the compressive strength after 28 days should be higher than 110%. And last parameter that you have to meet is basically to have air below 2%. So those are very, very simple parameters, you know, that you have to meet to have basically admixture certified, and you can start to offer this product or this type of product to the industry. If we look on ASTM C494, this is basically US standard for the same thing. You can see that the number of the admixtures is basically also designated to type A, from type A to type S. So for specific products, for the specific type of admixture, we have a different designation. And on the left side, you can see, you know, what are the criteria. Yeah, so there is additional thing that we have to measure. Setting times, you know, durability of the concrete, flexural strength. One thing that I would like to point out, if you want to basically have this product approved according to C494, you have to wait for 1 year compressive strength. Yeah, so if you compare European approach with 28 days and US approach with 1 year, you know, there is a lot of dynamic within the industry, you know, so sometimes you have to develop the admixture quickly and basically sell this product to the customers quickly. Yeah, in 1 year, a lot of things can happen. A lot of things can change. So, in my opinion, we are losing a little bit of flexibility. On the other hand, this is much detailed testing. We are basically testing durability, freeze-thaw durability, shrinkage, you know. So it's much more detailed, and if there is something detailed, it's going to take some time. So I think that we have to basically think about the balance between the time and number of tests that it's necessary basically to perform this type of testing. Another example is air entraining and mixture. You can see here basically 3 different criteria that you have to meet in the European norm. If we are going to talk about the US, is basically ASTM C260. And again, it's basically done after 28 days, but you have to do, again, freeze-thaw durability, shrinkage. So this could basically take up to, let's say, 3 to 6 months. Yeah, so in summary, and this is related just to admixtures. Yeah, so in Czech Republic, if you want to test the admixture in Europe, there is no need to use specific laboratory. You can go everywhere you want. In US, if you want to basically do that, there are 2 selected labs that they are basically testing all the admixtures. So there are some time limitations with that. More or less, all the testing is completed after 28 days. There are no requirements for the specific slump, for the specific mix design. You can use whatever you want unless, or you have to basically prove that, you are meeting very simple requirements. No limitations in terms of air content, and basically no durability testing, which is, again, as I said, we need to find the balance between the time and those durability testings. So if we look on ASTM C494 and C260, it's very clear that the complexity of the testing and also the WAL standard is pretty well done. It's basically very well set up, but it's gonna take a long time. There are various test methods in the standard that you have to go through to basically make sure that the admixture is meeting all the requirements. In terms of durability testing, as I said, this is much more strict. You have to test compressive strength, also the flexural strength, and all the requirements in terms of plastic and hardened concrete properties are much more strict. So, in summary, and I basically mentioned a lot of different things during the presentation, and I think it's important to basically cooperate together. Our goal is to produce good quality concrete, durable concrete, the concrete that is going to be sustainable. It's going to last long time. There is a lot of movement within the concrete industry, and we have to be flexible, and we need to basically adjust our approaches. Yeah. Again, from the example from Oscar, you can basically see the differences between 3 countries that are basically part of North America. Then we have basically Europe, Asia. Again, the concrete is still concrete. Yeah, so I think that we are going basically back to what Julitsa said at the beginning. One concrete world. Yeah, so we have to work together. So, guys, this is it from my side. So, thank you very much for your attention.